Okay, in our last video we looked at covalent bonding. Today we're going to actually do an offshoot of that. We're going to look at something called a polyatomic ion. And let's first define it, because a polyatomic ion is a little confusing for many students. It's a group of atoms, meaning two or more, that are covalently bonded and carry a charge. So it's a little bit weird to think about, right? It has the characteristics of covalent bonds, meaning there's sharing of electrons going on between two atoms, but there's a charge within the group, meaning it is an ion as well. So let's take a look at some examples here. And the first one's just hydroxide. And the hydroxide ion is OH minus, meaning there's a negative charge for the hydroxide ion. And let's just make some notes here. So there must be an extra electron, which means that this is an anion. Specifically, we said that it's going to be an anion carrying a negative charge. So let's do the same thing and focus on building up this molecule. So what I like to do is I just say, all right, I've got one oxygen atom. And oxygen is in group 6A, which means it has 6 valence electrons, for a total of 6 electrons accounted for that oxygen, right? And then let's think about hydrogen. Whoops, I misspelled oxygen there, excuse me. We have one hydrogen atom. And we know each hydrogen atom, in this case we just have one, has one valence electron. So we've got one electron from that. However, we also have one additional electron, right? That's what the negative charge indicated. So if we account for that one additional electron, we can add all of these up. And we could say, all right, we've got one additional electron. That means we've got 8 electrons total. All right, so let's try to build hydroxide here. So we've got oxygen and we've got hydrogen. We know that there must be at least one bonding pair between them, right? Because we said that there must be a covalent bond within the group. Okay, and then we need to fill in the rest. So we could say 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen's a little bit odd. In order to reach its nearest noble gas, helium, it doesn't need an octet. It only needs 2 electrons because helium only has 2 electrons. So when I look at this, I'd say, all right, because this has an octet, and over here, this is 2 electrons, like helium, that we're essentially satisfying the octet rule for each of these. So let's clean this up a bit more. We would say we've got oxygen with a single bond to hydrogen. And that oxygen still has the 3 sets of lone pairs left over. However, we have one extra electron. So what we do to indicate this is we put brackets around it, and then we put a little negative charge on the outside. So this indicates extra electron, meaning this is ionic. However, like I said, polyatomic ions are weird because it also has a covalent bond. So this is the weird thing that we have to deal with when we're talking about polyatomic ions, is it's a covalent bonded species that also contains a charge, therefore it's ionic and has properties of covalent bonds. Okay, so let's do another one. In this next one, what we're going to do is look at ammonium, which is NH4+. This is what's often found in things like Windex and cleaners. It's household ammonia mixed with water will form the ammonium ion. All right, so let's do the same thing. So we've got nitrogen. So we've got one atom. And nitrogen is in group 5A, which means it's got 5 valence electrons. So we've got 5 electrons. All right, we've got hydrogen next. We've got 4 atoms. And each hydrogen has 1 valence electron. So we've got 4 electrons from that. However, if we add all of these up, it's going to be 9 electrons. But that's not going to be quite right, because this is saying we have 1 less electron. So what I would do down here is I just say minus 1 electron, which means that my total, in this case, we're not going to add 1 to it. We're actually going to remove an electron from the total we just added. So we would have 8 electrons for NH4. So let's do the same thing. We've got nitrogen. I've got 4 hydrogens, so I'm just going to stagger them around. And we've got 8 electrons. And we know each hydrogen must have a shared pair to nitrogen. And wouldn't you know, we got it right on the first try. We've counted all 8 electrons. This central nitrogen has 8 electrons. These outer ones, just like we talked about before, want to be more like helium, so they only need 2 electrons. And we are set to go. Okay, so let's draw this out. So if we redraw this kind of down over here, we're going to have a hydrogen with a bond to nitrogen. This nitrogen will be bonded to all of the other hydrogens through a single bond. We do have a charge, so we're going to put this all in brackets. And to indicate that there's a positive charge, I'm just going to put a little positive symbol up here. So this would be the polyatomic ion for the ammonium cation. Let's try another one, and let's make this next one harder. Let's do NO2 minus. This is nitrite. This is something that's commonly found, unfortunately, in a lot of preserved meats. It's not very good for you. But let's go ahead and do the same thing. So we've got nitrogen. We've got 1 atom, times 5 valence, because it's in group 5A, which means we've got 5 electrons. And then we've got oxygen next. We've got 2 atoms of oxygen. And this is in group 6A, so it's 6 valence electrons. So we'd have 12 electrons from that oxygen. However, we've got a negative charge, right? So when we add this all up, this would be 17 electrons, but we've got an extra electron. So we would add 1 more electron to this, and we could say, well, this means that we've got 18 electrons total. So let's try this again. We have 2 oxygens and only 1 nitrogen, so that implies that nitrogen's likely going to be on the center. We've got an oxygen here and an oxygen here. All right, we've got at least 1 paired set between each of these atoms, right? So I always start with at least 1 paired set and then kind of fill things up as needed. All right, that means that we've accounted for 4, but we have 14 left over. So let's try adding them in. So we need 14 to get all the way to 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right? So if I look at all of these electrons, it adds up to 18, which is good. However, let's double check things. So over here, I've got 8 electrons. That's good. Over here, I've got 8 electrons. That's good. Let's check the nitrogen. Uh-oh, we only have 6 electrons for nitrogen, which means it's going to need to share from one of its neighbors. So let's try working on that. I'm just going to erase this, keep our notes kind of simple. And what I would do is I would just say, well, let's just share from one of these oxygens. So share so that nitrogen has octet. Okay, so let's kind of see how that would change things. So the oxygen on the left, really nothing changed with that one, so I'm just going to redraw it over here. The nitrogen in the center still has a lone pair on top, but now we're going to have two shared pairs between that oxygen and nitrogen. And we're going to have these two electrons left over, right? Okay, so now we can go ahead and check. This has 8 electrons, that's good. This also has 8 electrons, that's good. And if we look over here, now this has 8 electrons, which is good. So now everything's satisfying the octet rule. So let's clean this up and make it look prettier. We've got an oxygen that has a shared pair to a nitrogen, and that oxygen on the left had 3 sets of lone pairs left over. That nitrogen also had a lone pair on it, so we want to draw that. And then right here, because we have 2 shared pairs, we need to indicate that we have a double bond to this next oxygen. And that other oxygen has 2 lone pairs left over, so we could go ahead and draw these in. And like we said, we can't forget about that negative charge due to the extra electron. So we'll surround this in brackets and then just put a little negative charge in that top corner. So this would be the appropriate Lewis structure for the polyatomic ion NO2-, which is often referred to as nitrite. All right, I hope that helps, but let me know if you have any questions.